Hello, my name is Randy, and I'm going to be hosting a workshop on real-time sign language detection. So this is what we're going to be going over today. So we're going to go over the task, how we're going to approach this, and I'm going to help you walk through the code. And this will include designing a deep neural network and training the deep neural network. So American Sign Language is used for like deaf individuals in North America. So you can't hear speak, so they'll use sign language to communicate to others. So there are gestures for word, but for this project, we're going to consider the 26 letters of the alphabet. Okay. So we're trying to break this into two parts. So how are we going to build an AI capable of figuring out which letters are being signed in the video? So this involves like two parts. One, making sure the model detects the hands in the first place. So if I put my hand like up here, I put my hand like down here, it will detect where the hand is and where like each part of the hand is. And the second step is to see based on how the hand is like positioned, so like circular or like the shape of your hand, it will classify which letter it will be. So the model will input RGB images, and so it's just basically a picture of a hand, and it will output a vector which gives the probabilities of the letter it could be, and including space and delete. So 26 letters plus space and delete. So let's first go over how to detect the hand in the first place. So we're going to be using MediaPipe, which is a Google library for common video ML tasks. So it's supported on non-GPU platforms, and it's very like convenient for all types of videos, and it's easy to like use. So let's take a look on the website here. So you see how MediaPipe will be able to like detect like faces, like bodies, hair, but we're going to be focusing on hands. So if you go here, this is how we're gonna. This is what library we're going to use to detect the hands in the first place. So as you move the hand, it will detect like the positioning of the hands and like the orientation of it. So go back to here, and this does it, and this is able to detect the hand in the first place by using a single shot detector, or SSD, which we will not really be going into, but here's like a quick intro to what it is. So as you can see here, it's creating like a bounding box around the car itself. So what it's doing, it creates points of the car. So the top left, top right, bottom left, bottom right, and it'll tell you like create a bounding box using those points to see where the car is, to see like the shape of the car. But in our case, we're going to use 21 landmarks. So instead of those 4 corners, we're going to use 21 points of our hand, which can be seen here. Oh, oops. Okay, there we go. So based on the fact you're given 21 landmarks on your hand, and all the landmarks are adjusted relative to the wrist. So based on the positioning relative to the wrist, it'll tell you like what the general shape of the hand, and based on those general like relative locations of each landmark, it will try to get the shape of the hand it is in. So let's go to the code and see it in action. So first, this is just a regular hand detector model. So it has the complexity, like the hands, like it gets the shapes of hands, and the labels itself here. So this is step one, find hands. So what it's doing right here is creating, it gets the image of the hand and it pre-processes it here. So, huh? That's a prediction. Hands, and it will predict where like the hands are. So, and let's see. So this function just simply draw like the hands on. It'll predict where the landmarks are, and then this if statement will just say like if you want to draw the hands to be drawn on. So and then it will return the images with the landmarks. So this one is part two, step two. So if there is no landmarks, then it will detect nothing. Because if your hand's not there, then there's no hands to detect, and you can't. It's not really equal to a sign language. But otherwise, so for each landmark, this for loop makes sure that each point is relative to the risk. So no matter where I place my hand, it will still detect the general shape. And then this normalizes the array. So again, just make sure that the location of the hand itself is not impacting. Take the model and then it returns the gesture. So like the prediction, so like A, B, C, the letters and the delete in space. And what this function does, it does like a live video of your hand. So it's basically doing the first two parts in real time. Yeah. So if I run this right now, it should open a new window. This. Okay, for some reason the code decides to act up today, but but we have a demo video to show like how exactly it's going to work. So just give me a second to.
Actually, you want let's give
them to code it out.
close the repository.
You close the file.
Okay, so if you haven't closed the repository, go ahead and run it. There's a few adjustments you have to make first before it runs. Anyway, so we can just go in and walk you through those. So we debug that.
I'll set up to see. I'll set up to
You got it pretty good.
If it doesn't work, I'll still set up the video.
It was in the newsletter. Someone introduced me to it. Oh, okay, so first things first is getting good information. So when you call the repository, you want to check out the AI UCI branch. So if you don't know how that works, you can like check out.
It's in general, right?
Yeah.
Okay.
So let's just do a basic walkthrough for people who don't know how to use it.
Okay, yeah.
So again, you're gonna click on that green thing that says code. It's gonna copy that link. You go to your terminal or your command prompt, Windows.
Using IDE, you could also do it from IDE.
And yeah, so you're just like git clone, so you paste that link. And then once you have that link open, Randy goes back to you would want to type like git checkout.
So
Well, we don't just for demo, the git
So you'll
checkout.
be just yeah.
So if you type that and run that would get the description done. And from there, you would there's a few adjustments you have to make at the top of this code. So you just scroll to the top of get your detect.py.
Yeah, up here.
Yeah, so it might say like at the very top. In the imports, it would say import CNN as well. You want to delete that because that is no longer line 8. And then also on line 27, you want to make sure that self.model complexity is the third argument, not the last argument. It's like a version of it. So that needs to be updated. And yeah, so those are the two things you need to make with this code to make it fun in theory. Yep.
So model complexity, if you check that out, it's gonna be on your last argument. Make sure it's your third argument. So between max hands and self and detection con.
Although this won't work on all but yeah, we are because it's going to try to open the video. Pull out it's because a lot of running a virtual machine, so it's not easy.
The project will take a while to download. It's helpful to other data sets. I should have warned you that earlier. Okay, so what about OpenCV? You install the I installed everything. Yeah, you have the latest version of OpenCV to see error specifically. CV2 error. Source.mgn function CV.
It seems that the image you're trying to load isn't Is it because Zoom is using the video?
I think so.
Is that why?
Wait.
Is that why? No way.
Wait, okay, if I leave the Zoom meeting, no one's in the Zoom meeting list. So...
No one's in the Zoom meeting, but it would stop the recording. Like, what if you just turn off your camera and try to run it and see what happens?
Okay.
That would be the really funny if that's what caused it.
Okay, yeah, I think it's because of Zoom.
Yeah, wait. Just try running the They can't see.
It's running. Oh my god.
Okay, so
All right. I don't know sign language.
you can just make signs, and the funny thing is it'll actually tell you.
If I do like this, I can't advance the camera. There you go. It'll be if I do this, and if it's do a C, and then any suggestive symbols.
I think O is true.
Okay.
Okay, well, you actually know sign language.
No, I'm just making rules signs.
Wait, there's another type of sign. Oh, yeah.
There's one of different languages. Yeah.
Closed fish and E.
I think E is.
Is it like this?
Yeah, E is pretty good.
Oh, yeah. It's below.
E,
Oh, there we go.
Got it.
The other.
Okay, so
I think you got the idea. American Sign Language.
No, the line is deleting them.
Oh, okay.
So line 8, it says you're importing CNN, you can get rid of that. That doesn't exist anymore.
Are you able to get running on your computer?
Anyone not able to get it running? You're still running?
Yeah.
Oh, lots of people are still running. Okay.
Okay.
I think we can move on for now. Oh.
Well, let's try to play with this more.
Anyone loaned it and was not able to get it? So we can just run to the camera. That's your check on line 8. Yeah, so don't comment it out. This is the second. So the second import, there should only be one import on line 8. Don't delete the whole line. Just get rid of the CNN import. Yes, all yourself. Yes. So Python, you can. You. So you gotta go to oh, okay. Wait, is this is an anaconda? Yeah, so yeah, definitely, that's a different environment. It's using a different story than anaconda.
I'm sorry. I wasn't seeing
Right here. Do you want to move south up all the property or?
Is everyone so floating right now?
You don't want to come down morning? Let's go start one. Yeah. Awesome. Yeah. Good. Yeah, you're absolutely right. Okay, so you want to open gesture protect left line. There's an and yeah, open it. I know it's only on Mac, maybe it's something. Can you just is this good there? Yes. Oh, okay. No, let's put the new line on it. So backslash allows you to put multiple lines on it. So yeah. So yeah, this workshop was actually we had a lot on the material. Stuff like that. Ankita presented yeah, it was really good. Well, we're going to explain how it works. We should look at either hand. We can do left hand or right hand. It shouldn't matter. Yeah. So they did. Oh, okay. Okay. You want to move on? Are you guys ready to move on? We got it running. Okay, yeah. Actually, Erica's going to help, and then we can just keep it. Okay. You want? Yeah, I'll do one. Okay. AI UCI. Right, so moving on. So this model is using the deep neural network. So deep neural network is just basically just deep learning in general. So did I turn on the camera again? Oh, yeah. If you want. Okay. So let me turn on the camera. There we go. So, yeah.
So I think most of you guys understand like the basic idea of like a neural network, but I'll just usually go over it. If you have any questions, then I'll answer them on the spot. So first of all, you put the input through like the first layer. So all like input data. So in this case, it will be it will have an input size of 42. So it will be the XY coordinate of each landmark. So passing that input data, it will go through each layer, and going from each layer, each like input will have like it'll go through an activation function. So using like the inputs of the previous layer, each input a node takes has a weight to it or like importance, and it'll also have a bias, and each node has an additional bias. So every one of these nodes here, it will send an output like on or off, and this can be determined by passing the input values through the activation function, and then using the weights and biases, see if it reaches a threshold. So if the resulting value of the activation function is like above a certain value, it will send the signal. If not, then it will not send signal. So, and the reason why it's considered deep, it has multiple hidden layers. That's basically the difference between like regular neural networks and like deep neural networks. It just has multiple layers, hidden layers. So, is there any clarification questions about this? Yeah.
So like, are the signals within like in the middle layers, I guess, like you're saying, like with the activation function, is it all just like a 0 or 1, like a binary like signal from each node, or is it be like some variant value?
So the signals, so each like signal will be a signal strength, basically. So each activation will be like it will be like something like a signal strength. So it will be like a strong signal or a weak signal or no signal at all.
Okay. So there is not just like binary, there is some like strength to what it's outputting, like layers.
Oh, you're talking about activation function. Yeah, it depends a lot on how you design the network.
Yeah.
But generally speaking, it's I guess it depends on your activation function. It's like literally a mathematical function, right? So the two common ones are sigmoid, which will do this, it'll become from negative okay. It'll be like this. So it'll do 1 and up 0 and stuff until it'll be 0 and 1. The other common one is relative, which is like so it's 0 so I don't feel like this is there is sigma is more mathematically correct, but Relu works better at practice and faster. I'm trying to calculate the sigma function every time.
Anything else? So how does it like get those weights and biases, and how does the neural network learn? Okay, so you can break this down to 3 steps. So for propagation, so initially like each node has randomizes weights and biases. So we don't know what it is. So it's just like random guessing. Like imagine you're like taking a test and you haven't studied. So random. So it will take the input from the training data, and it'll go through each layer using the weights and biases for the activation function. Then, but that's for propagation. It's just using like weights and biases. It just passes like the data through and creates the output. So the next step is calculating loss. So how off is the prediction? So it just takes whatever the model predicted and compare it with what the output's supposed to be. So let's say that the output layer is a probability. It's not just like it's a probability of has output 28. So it'll be a probability of each guess. So the probability that it's A, probability that's B, probability that's C, etc. And what technically the output will be what will be the highest probability. So if it's wrong, if the highest probability is not what it actually is, it will adjust the weights and biases through backward propagation. So backward propagation says, okay, that didn't work. That's not a really good guess, but based on what we know, let's see what we could like tweak, what we could like clean up, and it'll repeat the cycle with like new training data, old training data, and eventually it'll see enough that it can guess like it'll get the correct output with a very high probability. Any clarification here? Okay. So now we're going to train the deep neural network itself. So you'll go to, let's see, model.py. So right here, this is the init function. So it just creates like the base of the model. So the self-hiddens are like the hidden layers in the neural network. And then the linear, it takes how much input and it outputs like the dimension. So this will be the input dimension and the output dimension. So for the first layer, the input layer, it needs to take an input of size 42, because that's where all the X and Y coordinates of the 21 landmarks are. Then these other numbers, they're like, it could be like random, so it could be like, it's arbitrary. There's not so much detail why these numbers are these like specifically, not specifically why it's 256, but generally it is they're usually powers of 2s and they're descending. So now you get to the final output layer, and it will output 28 or like 28 different probabilities that's A, B, C, D, etc. So this neural network takes in the input, which is size 42, which is like the XY coordinates of the 21 landmarks, and it outputs the probabilities of each letter based on the given landmarks. So this is a forward propagation. So it goes through the hidden layer, and then ReLU, as I mentioned earlier, which is the activation function, and then it goes to the next layer, and then it drops out. So does anyone know what dropout is? Yes, so the reason why we're dropping out some nodes is because you have the term overfitting. So basically, overfitting is like you're training a model and it gets very, very, very similar to the data. So it's just like at that point you're just like memorizing the data. And the purpose of creating a model in the first place is for it to read unseen data it hasn't seen, or like data or inputs it haven't seen before. So what dropout does, it randomly drops like a certain percentage of the nodes in the neural network, like each cycle through for backward propagation, just to prevent this overfitting issue. And then it goes to the next layer, and then the activation function, and then dropout, and it repeats that process. So you can choose the output. Any questions? Yeah. Right. So now that we have the base model, it's time for us to actually like train the data.
Yeah, actually, aside for this one, so if you have the Jupyter Notebook plugin for VS Code, you can run it straight through VS Code or whatever text editor you're running. If not, you will have to start Jupyter Notebook to start running this. If you don't have Jupyter Notebook installed, just follow like along visually for now, and we can work on that later.
So this will just import the libraries. So this will put all the libraries we need. Oh yeah, there you go. So if you're running this notebook as well, you probably have to change it. You have to also change like other pieces of code. So go to, let's see, needles.py, and you'll see _1 hot without any of like the f dot. So it'll just be this. You see in the code? So replace.
What did you change there?
So we imported torch.neural as f, and then for two of the one hot, put f, and then dot, and then remove the leading underscore. Continue. So again, we import all the data, all the packages, and then we create like objects that code the data. So this one, there's no normalization, or the bottom has normalization. This is just data code. This is like forming like the data set. And this is simply loads the data set into the object. So then we split up the data in training and validation. So so by doing this, we're making sure that we have like leftover data to actually like test the model itself. So we have separate data to train the model itself to see like it's like having a study guide similar to test. And the validation, it checks to see it runs the model and checks how much it gets correct. Like just testing unseen data. So then this samples the data for the split. But then I run the first one. Okay. Then this loads the data for sets. Then we create a skeleton model. Okay. Then loss function optimizer. So that's where the loss function calculates like how off the prediction is. And the optimizer is the one that helps like tune the parameters. So in the code, there will be no arguments passed through confusion matrix. Change that to 28. Oh yeah, and make sure you save the utils.py with the change in f.1 hot before you run the notebook. But else will not detect the changes. So right here. This is going through like the steps I mentioned earlier in like training the model. So for propagation, and then it calculates the loss, how hot it is. And then it does backward propagation to like tune the parameters to make it more accurate. Yeah. And then if I run this, see what happens. And now it's training the data if you run it. Oh, make sure you train the epochs from 2000 to 1 because it's going to take forever to train 2000. It's not going to be as accurate of a model, but unless you want to have a sleepover here, I would recommend it changing to 1. Is everyone caught up or want me to continue? Okay. So please do not save the model. It will save it into like a data folder. This is borrowed from someone else's project. Yeah, just don't save it.
You don't want to overwrite
You don't want
the version because the saved version is overwhelming.
So now it's just now this is the test portion to see how accurate the model is. So testing unseen data, these are all the labels that we'll be predicting. And this is loading the model itself. So let me load this. Right. And then it'll create like the test data for it to get tested. So now it's time for it to take the test and see if it passed. Oh, labels, did I not run that too? Okay. Yeah. It looks like it passed the flying colors. So, okay, yeah, one wrong. But overall, if you train it long enough, it will be like very confident in its correct answers. And we'll just have like tiny missteps like the last question. So, any questions? Right.
No, still running it.
Are you still running it?
Like, oh no,
Oh,
don't run the call out.
Don't run the call out.
So call out, you can't install it. It's stuff that only exists when you're running Jupyter Notebook via Google Colab. So that's like it's like an online version of Jupyter Notebook. So yeah, it doesn't get any run it.
So you can run it by the Colab if you're not going to use Colab.
Oh, for the vehicles.
Okay, so you're literally your model. So here, line 1, right after that, we're going to do another board. It's like color board. I'll use the board all over it. I can put what versus one height, you're not replacing the neutral with back down. Then now you're actually going to restart it. Turn on restart. You can do it. So you don't remember the first result. So something really good. Go down. Wait, no.
torch.nn dimensional.
Okay.
Yeah, I don't know. It's really weird. I ran the notebook 5 minutes ago. Then I tried to install Cloud after, and I think it messed with something on the library. It's really weird that you install. Yeah.
Why is it dying? Oh, we loaded a whole. Oh, yeah, we loaded a whole checkpoint, so. Okay. One spot. Yeah. Oh, really? You can get yeah. You can literally, I think you got it, like, you know. Yeah. But it's just like you say, like, yeah. It's fine, it's like one of those ones you like that, who I want for yeah, right. Yeah, because of the so we don't get like yeah. There's a bug. Yeah, there's like, no. So this is the first you bought, that's fine. It's going down. So we drink it when you talk with her. Well, I don't know where he goes. Yeah. So he's sitting. So. So he's dying. There's 16 days in it's dying for. It's dying when you try to roll the data. Yeah. That happens to me when I was coming. Is it when you? Maybe that's something. It wasn't installing something. You're trying to. Yeah, once he tries to load the data set, then I'll dive on. How does he try to? If you run that style, or you're in the style, that's how we're advanced. Well, that's good. Oh, you know what? It might be yeah, can you run user in that local, like, instead of going, we'll have to get that. You know, I suppose it. Oh, just. Well, yeah, no, I think it's because it's not the right folder. Because the path is not local. Yeah, just open it up. And now do speaking for there's two very big. Now for
Yeah, I feel like I'm not getting this right now.
oh, you don't want to. It's just a stop sign. And then you take it down. I don't know. Yeah. Those two cells are just good. I guess. When you're actually, so
No, I'm looking at it now and that makes sense.
yeah. So I guess the reason it's the common open source collab is because when you're actually training the model, you do want to use an environment that has a GPU, and I'm guessing most of you don't have a GPU on your laptop, but Colab has the GPU you use. So if you put that notebook on Colab and you run it, that would be like the where you would actually train it for like one amount of time. But yeah, if you're running on your local computer, you ain't done.
You have to do anything specific to like computer use your GPU or anything, or
So it depends. So there's in PyTorch, there's like a thing you have to do where basically you can take anything and you can call the block two, you can pass it to the light and see where it's that's the API. Yeah, so you have your, like, you would do something like model dot QGPU and then you just same thing for like the data. And you just do that for all that. TensorFlow, different library, you run it automatically, you have to do all automatically. Oh, sorry. Okay, yeah, there you go. Sorry. So yeah, this one is using PyTorch, so you would have to make sure that before you start training the model, you want to put the model on the GPU, and you also want to, whenever you load the data in the loop, like Randy, I'm not sure, can you show it?
Oh yeah.
Right, scroll down to the notebook.
No first.
Yeah, to like the start of the training loop. Okay. So right, so for zero says data and target equals batch, whatever. Right. So if you want to train on a GPU, you basically when you load it, you want to check it. You do that right on that line. That'll take care for us. So it's not too hard to get to use a GPU.
Yeah, we're done. So I'm just gonna end the workshop here. So you're all free to go. So thank you for attending this workshop. I know it seems a bit, we went through obstacles, but I just hope you got something out of this.